Hey, Honkai.
Hello, Mike. How are you doing?
I'm doing good. How are you?
Yeah, I'm fine. Let's wait.
Hey there, everybody.
Hello, how?
Let's see. All right, we'll wait a moment and then we'll get started. I've enabled screen sharing. All right, why don't we go ahead and get started? Welcome everybody to the Tuesday, May 31st, 2022 meeting of Kubernetes SIG Multicluster. I believe we have one entry on the agenda today, and that is from, is that you, Rainbow Mango, that had that one today?
Yes.
All right,
Yeah.
go ahead.
Okay, I'll share my screen. Okay. Can you see my screen?
Coming through loud and clear.
What? Sorry?
We can see it just fine.
Okay, okay. At the last meeting, Mike presents the proposal about how to sync status for the work API. And there is another solution in the proposal that adds a status field to the status. Here today, I'm going to share some information from Kamada system. Use this solution. Okay. Sorry. Okay. Before we talk about the work API, I'm going to introduction Kamada system. Kamada is the Kubernetes management system that enables enables you to run workloads to across multi clusters. Kamada is developed in continuation of Kubernetes Federation v1 and Kubernetes. Some basic concepts are inherited from these two versions. Though that's the reason why some people say Kamada is the next generation of Federation, or Kamada is a Federation v3. Okay. Here is the Kamada architecture. The architecture of a Kamada is very similar with the Kubernetes. The Kamada API server now built based on Kube API server. So that's the reason why Kamada compatible with Kubernetes native APIs. And Kamada extends the API by both CRD and aggregated API server. The Kamada scheduler takes the responsibility to schedule workloads to member clusters. For example, deployment might be propagated to member to cluster 1 and cluster 2. After the schedule decision made by Kamada scheduler, the controllers will put the workloads to a namespace we called execution space. Each cluster owns one execution space, and after that, the execution controller, which more like the postman, will applies the workload to the memory cluster. Here is the core concepts of Kamada. First, the result template. Let's take deployment as an example. After we applied a deployment to Kamada control plane, there will be no pods created. We treat the deployment as a template. As mentioned before, Kamada extends the APIs by CRDs, such as the propagation policy, resource binding, and override policy. And the work API comes from the Kubernetes SIG Multicluster. The propagation policy defines the scheduling rules about how and where to apply the resource template, and the resource binding used to hold the scheduling results for each resource template. And the override policy defines the rules about how to override the resource template. For example, the image registry might be different for each clusters. This is the Kamada workflow. After a resource template is applied to Kamada control plane, the controller will set up a resource binding for the resource template as per the rules defined in propagation policy. And then the scheduler will select clusters for the resource templates and applies the scheduling decision to the resource binding. And after that, the controllers will create work objects for each cluster. And finally, the execution controller will apply the resource templates to member clusters. Let's hold on for a moment. Any questions here for the Kamada introduction? Okay, I take silence as now. Okay, that's how we changed the work API. We introduced a status field with the raw extension type. The status can be used to hold the whole status or the fragment of any resources. Let's take an example. Here is a work example in Kamada. From the identifier, we can know that it holds a deployment, and the status represents the fragment of its status. You can see that the status node is different with the Kubernetes deployment status. It's just the fragment of the status. Here, the question is, how do we know how many fields or which fields should be put into the status for each kind of a Kubernetes resource or CRDs? We use a framework named resource interpreter to decide it. It maintains some built-in methods about how to grab status for Kubernetes resources and some well-known open source CRDs. People can customize the methods, the methods if the built-in methods doesn't fit their needs. And in addition, people can customize the methods for their private resources. For example, for the private CRDs. Okay, here is the resource interpreter framework. In Kamada, during the process of propagating a resource to member cluster, we need to detect the resource in structure to get some information, such as how many replicas in it, or how to update the replicas. Actually, the status functionality is just one of the functionalities of a resource interpreter. It the interpreter status, we call that a function. Yeah, it helps to grab status for any kind of resources. We defined a reflect status interface, and we can implement the interface for each Kubernetes resources. There are two kind of methods in the interpreter status. One is the built-in method, which maintains by Kamada community, and it employs most of common used resources such as deployment, default site, daemon site, job, and so on. User can extend the method to add any resource type they need. if people don't want to modify Kamada code in tree mode, they can they can implement a webhook to customize customized methods have higher priority than built-ins. Here is the example of the configuration example of the resource interpreter webhook. People can define their webhook URL. And here, the configuration is more like the Kubernetes mutating configuration. Yeah, something like that. Yeah, any questions from here? Okay. The future of a resource interpreter, we are gonna to try some thing like customize the behavior by configuration inside of the webhook. In that case, people don't have to implement the webhook, and people just have to teach Kamada how to do it.
Could I ask one quick question?
Okay. Sure.
So kind of in the helpful flow diagrams you had a few slides ago, this kind of interpret status, am I right in thinking that its purpose is simply to sort of propagate the status back from the child cluster to the work custom resource?
Yeah, yes.
And so I guess, like, does this go along with, or kind of, or maybe this is a higher level question in general for how this reverse status propagation works, or in what cases it's useful, but is the end goal to have that propagated all the way back up to the original template resource? For example, I think there was a separate stage you had there, like an aggregate status, or is the goal here only to propagate status back to the work resource and sort of stop there?
I'm sorry, I didn't follow you.
I guess I'm just wondering, is the goal to get the status all the way back to the original resource that was applied to the Karmada API server, or is it just to propagate status to the work custom resource?
Yeah, good question. I get it. Here I back to the previous slides. Here we are talking about the interpreter status. Each focused on manage the status from memory cluster to work object. Yeah, this is the interpreter status. And after that, we also have other functionalities. It takes the responsibility to aggregate the status. For example, after the status is grabbed to the work object, and then the status will be transferred to resource binding, and then another function I see aggregated status used to it helps to aggregate the status to the result template.
Okay, I see. That makes sense.
Okay.
And this proposal that you're talking about is purely this latter, this interpret status piece.
Yeah. Yes. Exactly.
Mhm.
Okay. Let's move on. Here is yeah, I think it's the last slash. Here, and my question is how do you think the solution and yeah, the description here might be different in our system. It's, for example, it didn't ticks all the status here. We just pick some of the status. Yeah. Any comments?
I would like to ask, what do you think about, so we like the fact that we should have more flexibility in the work API proposal to hold other fields such as the var type. So in the proposal right now, Qjang mentioned that we'll fall back to a var string. If you go back to the PR,
Okay, I see.
so what do you think about that? So the reason we want to fall back to a var string and so var extension is because echoing what the API machinery maintainer mentioned, var extension as documented right now is it says it's supposed to hold the complete Kubernetes object with the API version and kind fields. So we feel like the var extension might not be the right type to hold the var object. So at the bottom, if you scroll to near the bottom, I think.
Near the bottom. Okay.
Yes. And then I think
Here,
yeah. Scroll up a little bit, and then yep, right there, the var string. So Qjang is proposing we use var string because then that's a little bit a better type. And I'm interested to hear the feedback from the community on that as well. Paul, for example, and others.
yeah. I don't think the field value is the main concern of the proposal. My concern is the rules about how to and how to collect the status for a resource should not define in the work API. Because the work API is it's a specific object. For example, you can define a rule for deployment, but I don't think the rule should be put into the work object in different work objects. I don't think I'm not sure if I.
Yeah, I think we discussed that in the PR as well. We mentioned that instead of having the rules hard coded defined in the work object, we'll have a reference to another object. So in the work, it'll be we'll just have a pointer to that object reference to that rule or policy that defines what status to capture. But going back to, let's say we have the rule capture, and then you mentioned that you would like us to store more values outside of integer, string, and boolean. So do you think having this var string is enough to satisfy that requirement,
Yeah.
or you still prefer var extension?
Actually, I asked the example from Qiujie, and she gives an example here. I think it might be looks like a little bit ugly. No fun.
Yep. But the interpreter of these resources or this CR is usually machine. It's not meant for users to consume, right? Is that
Yeah. Yes,
a
I
fair point?
agree that the work API should not be intended for user to consume. But if people debug on it, so for example, it could control get the work object. This way might be looks not so good.
I agree with that as well. I guess the concern with var extension is it's mainly it feels like it blows the API all open, and just based on the definition, it says it's supposed to hold the complete Kubernetes object with the API version and kind. So that is our only concern here, because in the work API spec, it does have the manifest view, and that manifest view is a var extension, but that actually holds the complete Kubernetes object. And here you're proposing we're only returning the status part. I mean, and the status is not a complete object, right? So that's where we're a little bit stuck on, I guess. So we would love to hear more feedback from the outside community because of this topic. Paul, do you have any do you have any comments or anyone else?
So I think what I'm trying to understand is the interpreter piece. Can we go back to that for a moment?
Okay.
So specifically around, let's talk about the piece that had the field referencing a Lua script. Can we do that really quick? I think that was one of the last slides that you showed.
This one?
Yeah, so one thing that wasn't clear is whether status interpreter was in work API, or is this in a layer that exists in Karmata?
That's our this status interpreter structure is now is in our proposal. We haven't implemented it. So
And
that, I suppose the configuration should be done by some APIs like this. We define a rule about how to collect the status from the memory cluster for a resource. Yeah, that's the, yeah, I think for example, we can specific a rule for deployment. We can create the configuration with this, something like that.
so would this be proposed to be at the work API layer, or would this be in something that would use in program work? Does the question make sense?
Yeah, I want if we can work out a common API. I think I'm okay to put it in the work API.
Okay, sounds like it doesn't necessarily have an intended home yet. In general, here's what I think this resource is for. I only have a few minutes. I've got to stop at 5 after, unfortunately, but it sounded to me like this resource was to characterize a reusable piece of configuration that knew how to unpack the status from something that was delivered by work and return I think it was a manifest status. Is that correct?
Yes.
Okay. With the goal being to, and this touches a question that was asked earlier, just to make sure that I understood. The goal of doing this is to surface the status, if it is desired to do so, surface the status of resources deployed by a manifest work into the manifest status field of a manifest work, right?
Sorry. Sorry.
So if I understood correctly, status interpreter was the job that status interpreter has is to reify the status of a resource that was deployed by a manifest work back into the manifest works status, right?
Yeah. Yes, exactly.
Okay. The one thing that I'd offer is that inserting scripting into a resource like this is something that there's prior art and discussion on that you may want to locate within, for example, the Kubernetes repo itself. There were, for example, I want to say that there were issues raised about turning config map into or using config map as a template that would have similar semantics to the scripting field called retention Lua in this example. It's definitely something that I would spend a little time trying to understand the prior art and discussions on semantics of putting any kind of code type of content or script type of content into a field like that. Yeah, that's probably the thing that jumps out at me for now. I don't know if anybody else like had a light come on their dashboard seeing the embedded Lua there, but that was one thing that jumped out to me. In general, I think it makes sense that manifest work would encapsulate, being able to understand the status without having to go out to the remote cluster. One thing that was raised previously that I didn't see represented here today was about the configuring the frequency of the updates and fidelity of the status. So for example, if for example, we would expect to represent every single status change, like watch event by watch event, that's a very, very different level of QPS that's required, as opposed to saying that like the status as reflected on a manifest work is no more than 5 minutes out of date, is no more than 10 minutes out of date, is no more than 30 minutes out of date. So I think it is important to have the discussion on QPS required to support these different levels of status aggregation as we have the conversation on like what the API constructions are to capture the transformations, because in a sizable deployment where you forget about scale of number of clusters for a moment, like in a deployment where there are large numbers of resources, the QPS required to reflect their status could absolutely become one that might significantly compromise the scale that manifest work could be used at. And normally I would expect that, for example, there are different parts of the lifetime of a resource deployed by manifest work where different levels of granularity for status updates are required. So like one other thing to throw out there around QPS management would be that if I think of a deployment, there are, for example, different parts of that deployment's lifetime where when we initially create a deployment, we're frequently very interested in the status for the next 5-10 minutes, or until the number of replicas we desire become available, after which we're probably not going to look at that status every moment for some amount of time, right? So I think it would be worth characterizing patterns of QPS use to encompass things like, we're probably most interested in the status of a deployment after the spec changes or it's initially deployed, right? I think that would certainly be information that would help folks understand what the steady state QPS patterns look like that are important to understand as we talk about the API constructions. Unfortunately, I've got to stop now. You are all welcome to keep going through the end of the time, but I need to drop at this moment. Thanks a lot, Rainbow Mango, for coming and presenting today.
Okay.
Thank you, Paul. So, Honkai, is there in Kamada, is there something that related to what Paul was talking about regarding QPS? Like, how do you configure in Kamada how often the status sync?
For now, Kamada syncs the status for each status change. Yeah, I agree with Paul mentioned. Yeah, we should consider the QPS thing.
So is the configuration of the QPS also inside the work API spec? Is that something we have to enhance in this proposal? Do you feel like we have to enhance this current status return proposal with a QPS field or something along that?
Do you think we should start another API to hold the configuration, including?
Absolutely. But I think in the proposal we mentioned that the work API will have a object reference to the rule. So for example, if we were to use status interpreter, it will point at the status interpreter. So that leaves it a little bit more open.
Okay. So how about let's work together to try work out the configuration, and the configuration API defines how to sync the status, and yeah, we also put the QPS thing in the configuration.
The QPS should be in the configuration. Okay, yep, that sounds right.
Yeah. Okay. Let's assume that we are gonna have a new API. Yeah. So back to the proposal. How to define the status thing still. Yeah. Now, how to show the status? What's your opinion now? Is this way acceptable? Yeah, ignore the field type. We can change to something like byte slash.
I feel like so leaving it as a byte slice or leaving it as a var might be a bit too open. I feel like if we have the predefined fields that we specific the type of the status, that may be a little bit safer in terms of security. But we do have the var byte to fall back upon. So something like what Qjang suggested, I feel like that might be a better approach where it's up to the consumer of the API if they want to use a type for safety, or if they're willing to give up some of the security and use a more open type such as bytes or var or something else. What do you think?
Yeah,
because on the status part, it's actually returning from from a cluster back to the centralized or hub location. So we kind of want a little bit security around that, unlike the work spec, which is defined from a centralized location and propagate down, where we can be more open and say, hey, here's the raw extension for the whole object. Because this is coming back from this is returning back from a member cluster, we feel like it's better for security if we have some type of type definition to ensure that, maybe the data is not too big against a malicious actor, for example. So that's why I think Qjang and Min Kim and some of the folks mentioned that we should have some type defined, but we also allow for the a little bit more open if the consumers of the API is willing to have that risk. Stefan, do you have any opinion about that? Sorry to, to put you on the spot.
Yeah, not right now. No, I'm still discovering this, so I'd have to think about it a bit more. But yeah, it does feel like I tend to be a bit wary of wide open APIs that just allow anything.
Yes, I think that was the common feedback from the community as well, where it's probably better to have some type as the return.
Yeah.
So if you don't like the raw JSON, maybe we can Honkai, we can change it to something else. And if you we
I think the string here. What's the difference between the string with and the raw status, the extension? What's
I
the
think
difference?
it's mostly do with the fact that the raw extension based on the documentation is supposed to hold the entire Kubernetes object. That's that is the only I think that's the only concern.
Yeah, I got it. how do you think the byte slash?
I'm
I think-
okay with it.
Yeah, I think it's more byte than the string.
I'm okay with the byte slice. Can you mention that in the comment to QGen, and then see what his feedback is? I personally is okay with the byte string because I don't see the difference between wash string and the bytes. But maybe wash string is a little bit more readable than the byte string. That's the only feedback.
Okay, sure. I'll do that after the meeting.
Thank you. So on this proposal where it's currently defining the rules, I guess we're gonna change it to a reference to something else, and then okay. And do you want this proposal to also include that new API, or do you want to make another proposal, or how do you want to approach that?
Both okay to me.
Okay, then we'll work together, and then we'll enhance this proposal then and just encapsulate everything here. Then we don't have to flip back and forth on the PRs.
Okay. Okay. So how about we work together to work out the new API, and after the API we go back to how to show the status in the work API.
Sure. I just want to ensure that we also take care of the QPS as well, because it seems like that is something that Paul mentioned that have a
Okay.
really good point about, as well as the lifetime of the status return. I guess that's not a QPS because that is so. Paul mentioned an interesting point where we're only probably interested in the status after a spec change, after a certain time period. We might not need to continuously watch it. So maybe we have to take care of that too, whether it's in the QPS or maybe like another field where like a life, like how long it lives for, that type of field.
Yeah. I think, yeah, it's reasonable. Okay, Mike, I think the meeting is no time left, I think. I guess.
Yep. Thank you so much for presenting and coming on. I know it's
Okay. Any questions from questions? If no questions, we are going to end today's meeting. Okay, take silence as no. Okay, bye everyone.
Thank you. Take care. Bye.
Thank you. Bye.